We're solving radical equations and radical inequalities, and here we have an example of a radical equation. The first step when we solve it is we want to isolate the radical if necessary. So on the right side we are isolated, but on the left side we're not. So we have to try to get rid of this radical here. And so what we can do is we can square both sides. And what we end up with is we end up with the square root of 3x minus 8 plus 1 times the square root of 3x minus 8 plus 1, and that is equal to x plus 5. And then when we go through and we distribute this, the square root of 3x minus 8 times the square root of 3x minus 8 is 3x minus 8 without the square root on it. 3x minus 8 times 1, that is going to be plus 3x minus 8 square root. Same thing, 1 times 3x minus 8, square root of 3x minus 8 is plus 3x minus 8 square root. And then 1 times 1 is 1. And then the right side is still x plus 5. Then we can combine some like terms. We have a negative 8 and a positive 1, so that becomes 3x minus 7. And then we have a square root of 3x minus 8 and a square root of 3x minus 8. So that becomes plus 2 square roots of 3x minus 8. And that is still equal to x plus 5. Now we have one radical left on the left side, and we need to isolate that in order to get rid of that radical. So the first thing is we can subtract 3x and we can add 7. So we'll subtract 3x and add 7. So then we get 2 times the square root of 3x minus 8. That's on the left side. And then on the right side, we get negative 2x plus 12. Now we need to get the radical by itself, so we still divide by 2. And what that gets us is the square root of 3x minus 8 is equal to negative x plus 6. Now we need to get rid of this radical. So inverse of the square root is if we square it. So the square cancels the radical. And we get 3x minus 8 is equal to negative x plus 6 times negative x plus 6. And then we get 3x minus 8 is equal to x squared minus 6x minus 6x plus 36. 3x minus 8 is equal to x squared minus 12x plus 36. So we have a quadratic formula on the right side. So we have to get the left sides equal to 0. So what we want to do is we want to subtract 3x and add 8. So subtract 3x and add 8. And we get 0 is equal to x squared minus 15x plus 44. And fortunately, we can factor this. So 0 is equal to x times x is x squared. And two numbers that multiply together to 44 are 11 and 4. But we need the middle term to be negative. So if we make them both negative, then negative 4 minus 11 is negative 15. So we have our possible solutions. And so we know that we're going to check to see if x is equal to 4 is a 0. And we're also going to check x is equal to 11. So we're going to substitute those back into the original equation and see if those work. So we can check 4, the original equation. 3 times 4 minus 8. That's all under the radical. Plus 1. We're going to check and see if that's equal to 4 plus 5, all under the radical. 3 plus 4 is 12, minus 8 is 4. Square root of 4 plus 1 is equal to the square root of 9. Square root of 4 is 2, plus 1 is 3, so 3 is equal to 3. So we know that 4 does work. Then we have to check 11. So 3 times 11 minus 8, that's all under the radical. Plus 1 is equal to 11 plus 15, or 11 plus 5, all under the radical. 3 times 11 is 33, minus 8 is 25. So we have the square root of 25 plus 1 is equal to, we have the square root of 16. So then we get square root of 25 is 5, plus 1 is 6. 6 is equal to 4. That's not true. So 11 is not a possible solution. So the only solution for this one is x is equal to 4.